Hello students. So remember that previously we used an equation like this to calculate the force of gravity, where G is 9.8 newtons per kilogram for the surface of the Earth. You can also calculate this G for anywhere you are in space. So again, we have an example here of a planet with radius RP and something in an orbit around it, a satellite in an orbit around it, at a height above the surface of h. So there is a different g constant for this distance above the surface of the planet, this distance from the center of the planet. We could calculate that using Newton's second law. So we could say if this is an equation for force of gravity, this is also an equation for the force of gravity. We can set them equal to each other. So we can say that mg equals g mm over r squared. So the thing that we're interested in, the satellite in this case, is this m. So let's label that m sub s for mass of the satellite. The planet is the other object, so let's label that capital M with a P. Now you can see that mass of the satellite divides out, and we're left with our G constant is equal to capital G, constant of nature, mass of the planet over r squared. So this is true anywhere, any distance. If we calculated it at the surface using capital RP for r squared, we should get 9.8. If we calculate it out here using g mass of the planet over rp plus h, that quantity squared, we should get a new value that represents the different gravitational strength at that location. Thanks for watching. Remember, what one fool can understand, another can.